Section 24.7 Global Circulation Patterns. Cell-like circulation patterns are responsible for heat distribution and global winds on the Earth. At the equator, you have hot, moist air that rises straight up with very little horizontal movement. Because of this, you get very little wind near the equator, but you get lots of rain. And so you find that you have a lot of rainforests and things in this general area. At about 30 degrees latitude, the air cools and it sinks, and it becomes compressed. Here you have a region of high pressure where the air is pushing down, and this dry air gives rise to the deserts that we find on the Earth. At the poles, the air is cooled, and it's compressed there as well. However, the high pressure at the pole pushes the air outwards towards the equator. The cold air then meets the warm air from a region known as the westerlies at near the 60-degree latitudes, and this often results in storms in this general region. Similarly, because of the interplay between the winds from the equator to 30 degrees north and 30 degrees south latitude, the weather in this region is often unpredictable. In the upper troposphere, there are high winds or rivers of air that are called jet streams that move air very quickly across the surface of the Earth. Two important jet streams are the polar jet stream, which is caused by a steep pressure gradient at the 60-degree latitudes. This is very strong in the winter, and it moves to lower latitudes and allows for cold air to come down in the winter months in North America. In the summer, the polar jet stream is weaker, and it moves to higher latitudes, and warmer air generally covers North America. Also, the subtropical jet stream at the 30-degree latitudes leads to monsoons in Southeast Asia, both in the summer and the winter, depending on the direction of the airflow. In the water, like the atmosphere, we can divide the oceans into multiple different zones. We have a surface zone, a transition zone, and a deep zone. And there are two major drivers of ocean currents in the water: surface currents and deep water currents. Surface currents are driven by friction with the wind. Smaller bodies of water will move with the direction of the wind. Larger bodies of water will move with the direction of the wind as well. However, they'll also be affected by things like the Coriolis force, and those currents in larger bodies of water will be deflected. In very large bodies of water, the Coriolis effect and the pressure gradient force can cause water to flow in circular patterns called gyres. One result of this is the Gulf Stream, which circulates in the Atlantic, and it brings warm water and a temperate climate to northern Europe from the east coast of the United States. Deep ocean currents are driven by gravity. Colder, more dense water sinks down, and this water forms a global conveyor belt across the surface of the Earth, but underneath the oceans.